Hello, everybody. Make yourself some popcorn, pour yourself a beer. This is going to be a giant lecture by Jabali all about two of my very favorite topics, which is nomenclature, or the naming of botanical entities, and taxonomy, the classification and ordering of all of this biodiversity. We're definitely going to talk about indigenous ways of naming, as well as kind of the progression of Western science towards having a classification that represents the evolutionary history of plants. All right, here we go. Okay, so we were reminding ourselves of kind of the Linnaean hierarchy here. Now let's really start to dive into the names themselves. Okay, so nomenclature is the using of names. And we want to be able to identify and name species. We're working on that a lot in this class. And we also want to place each individual species within higher classification groups, kind of a nested hierarchical classification like we see here, where the lady slipper would be placed. Okay, but what do we call things and what information is being transmitted? So think on this. Which of the following is not a true rose, therefore placed in the genus Rosa in the Rosaceae? The moss rose, the Lenten rose, the rose of Sharon, the hairy alpine rose. These are all common English common names for various species. So is a rose, is a rose, is a rose, is a rose, as Gertrude Stein said. We'll find out in just a moment. So common names can be really useful. For whatever reason, there's certain plants that I learn best with English common names. And I just kind of come back to them time and time again. They're a great way to communicate with non-specialists. So I use them, and we're learning some of them in this class. Sometimes common names are really descriptive and colorful, and they tell you something about the thing that you're looking at or looking for. They're easy to remember, and frankly, for many people, that's really the kinds of terms that they're comfortable using. So many botanists have to get kind of familiar with common names, even if they don't really like the idea, because that's just, frankly, what they need to do to communicate. However, there are some distinctive disadvantages. I'm all paranoid that my Zoom isn't actually recording. So I'm going to check real quick, because if that happened, I would be the saddest Jabali. Oh, it is. Hi. Okay, back to my business. Can you imagine if I had to do this all over again? Oh no. Okay. Hiding this thing yet again. I won't recheck that. Okay. So what are some of the problems with common names, particularly in plants? And I think I've mentioned that in the birding community, at least in the English-speaking world, as I'm aware of, common names have actually been standardized, but that's not the case in the botanical world. Well, there's not a one-to-one correlation. One scientific species might have many different common names, even just in English. When you take languages outside of that, including indigenous names that we'll talk about, there can be many names, like the white water lily here, right? Which has so many, 245 common names. The Latinized nomenclature, though, solves all that. There is one. This is Nymphea alba. That's it. Sometimes you can have one common name that's applied to multiple species, like fireweed. The word fireweed could be applied to two very different genera within two very different families. Names can be straight up confusing. This is called sweet fern. It is an angiosperm and not a fern at all. So that's straight up confusing. You can probably think of some that have confused you in the past. Pineapple. I studied the pineapple family. It is neither pine nor apple. Spanish moss in the pineapple family is neither Spanish nor a moss. Super confusing, yes? Welcome home, husband, no matter how drunk ye be, or hen and chicks. That's some like old English nonsense there. It's hilarious, but not particularly useful or descriptive. So back to this question, surprise, surprise, none of them are actually in the genus Rosa. They're in four very different plant families. So they're all kind of rose-like, but that is not botanically accurate at all. The other problem about common names is there's so many species out there that don't have a common name. So what botanists and other people do when they feel the need to apply a common name to something like Carex buxbaumii is they just say something like, this is Buxbaum's sedge. Buxbaum would have been a last name, but that's not actually a thing people talk about, like common name level people talk about that. So it's just sort of an artificial construct. So hopefully you can see that a standardized way of communicating about biodiversity across cultures, across languages, and even across time is really, really necessary and useful. All species need names. Things that are named can be studied. They can be protected. We have like the Endangered Species Act, et cetera, et cetera. So we need a uniform and stable system of naming to avoid confusion. And we want the names to mean something. So the names and then the classification scheme around them should facilitate information retrieval. It should make sense. Like how you know when you go to a library and you know where certain book stacks are. Because of the ordering of where the books are placed, it can tell you information about what's around it. There is a governing body of botanists that every 6 years meet and update and revise what is called the International Code of Botanical Nomenclature. There are similar codes for animals, microbes, etc. But this is a document that governs how we name things. And sometimes when people want to change names kind of in opposition to the code and the set of rules, the group can vote on it. So we will be meeting in Madrid, Spain in 2024 for the next iteration of that. And the last one was in China. Okay, sometimes scientific names are actually descriptive if you know a little bit of Latin, okay? So this is the May apple or Podophyllum peltatum, which is in the Berberaceae, found out east. And it's called, if you translate the Latin, umbrella foot leaf is what it would be translate to, which is a pretty accurate description for this peltate compound leaf. Okay, well, how did we get two name species or binomials? A genus plus a specific epithet is a binomial. Well, prior to binomials, the Western scientific world, including Linnaeus, before he really standardized things, here he is leading a field trip out of Sweden in the 1700s, you would have talked about species in long polynomial kind of phrases or sentences. So a phrase like this, more than 2 words, would be describing a species. So it would translate to the species of Serratula with leaves oblong to amblanceolate shaped, serrate edged, and drooping. Okay, so that gets pretty darn cumbersome to have like a whole phrase as the describer. And so hence why having a binomial that's a stand-in for all of those features that are published somewhere is what was decided upon as the most useful system. Okay, so we have the binomial species name, right? 2 words together make up the species name. The genus Serratula is capitalized. italicized or underlined. And of course, the plural of genus is genera. The second word is the specific epithet, not the species. The two words together make up the species name. The second word is never capitalized, even if it's named for like a person or a nation, like Canadensis, etc. Don't capitalize it. There does have to be Latinized agreement in gender between the genus and the specific epithet, with some weird exceptions, like trees are allowed to be feminized even if the genus is masculine or neuter. So there's some weird kind of holdover stuff like that. But in general, they have to agree. Sometimes in scientific publications or other places, you will see a third thing after the specific epithet. So in this case, L dot. That is what's called the authority, or the person who described that first. So L dot stands for Carolus Linnaeus, Carl von Linn, the founder of our modern system of nomenclature. And he's so famous, he gets to be just L. So there's quite a few taxonomists like that are so prolific and famous that they go by short abbreviations. I'm not that. If I were to ever describe a species, it would be full-blown Jabali written after that. Okay, sometimes you will see multiple things after the specific epithet. This is part of the process of understanding synonyms or duplicate names. Okay, so there was an original species, Serratula novaboracensis, and then described by Linnaeus. Subsequently, the famous French botanist André Michaux transferred this plant to a different genus, Vernonia, based on evidence. His concept of Vernonia said this should be part of Vernonia. So the name now carries kind of that edit to it. So what you see is that the authority is Michaux, who came up with the combination of Vernonia and novaboracensis, but we still have L in parentheses at the very beginning, because he was the first person to use novaboracensis, the specific epithet for this particular species. So both pieces are there to kind of follow through on that scientific history. Okay. So it became very clear early on that names were going to change, especially people working in isolation from each other might be describing the exact same thing. One of the rules that we'll see is there can only be one scientific name for one entity. We can't have multiple that are equally valid. So it became clear that every single name had to be tied to a type specimen, which can be used to track names and lessen confusion. So every single species name must be linked to an herbarium specimen somewhere in the world that is formally deposited and made available for public study. The name of that very specific specimen is the holotype, the singular particular specimen designated by the author of whatever taxonomic unit, a species or variety or something, that fixes that specimen to that name. So many times the person that actually collected the plant describes it. And so it would be the collector and the describer of the species would be the same. But in some cases, that's not true at all. Plenty of people come along after the fact and describe species or revise species that others have collected. Now, there's a whole other series of type names, isotype, neotype, et cetera, that I'm not going to get into. But in the event that something happens to the holotype, there's ways to elevate another specimen to being that. Like there can only be one Queen of England, but then there's a bunch of other people as successors all around her. Similarly, there's other specimens that could be elevated to holotype if something were to happen to it. Okay, so say in your ramblings about Colorado, you find what you think is a new species of cannabis. Woo, that's exciting. It's unlike anything you've smoked before or seen. Well, what could you do to describe that? Well, first of all, you have to figure out what are all the other species of cannabis that are out there. And you have to find a binomial that's not already taken. There's quite a few actually out there. So these are all occupied. You can't use those terms. Those are separate things. You think you have a new thing. Now, there are lots of kind of conventions about what you should name the specific epithet for. So you know it's in the genus cannabis, but what's the second word going to be? Many of the specific epithets are about places where something was described. Many times they emphasize a key feature that differs from something else. They sometimes are named for people. And, you know, this has a very kind of problematic history. And I get kind of upset, frankly, especially recently when I see botanists continue to name new species for, you know, predominantly white, predominantly male, predominantly European or American botanists when those plants live, frankly, in areas of the tropics, etc. I see this happen all the time. And then the people in those communities are kind of forced then to use those words. What I really like, and I'm seeing done more recently, is when botanists will use and acknowledge the indigenous people of an area with a specific epithet. That is being done more and more, and there needs to be a lot more awareness of that. Now, you can always do something like name it after someone real famous who inspires you, and this can often get you a lot of press. So I might name it after Obama. Yay. So cannabis Obami. And then I would slap my whole name on the end of it because I'm not that famous, right? Okay, so I would have to make a specimen of it and deposit it in a valid herbaria, of which Colorado College is. So it might be my 606 specimen and it lives in Cocoa. Then I would have to describe it. Now, that used to have to be done only in Latin, which is frankly a major impediment to new species discovery because, like, frankly, most practicing botanists are not well versed enough in Latin to just write that out. So you'd have to find someone who was to help you. Now, back in 2011 at the IBCN meeting in Melbourne, I was there. They, after much heated debate, agreed to allow new species to be described in English and I believe also in Mandarin. Now, it used to have to be all that stuff, the new description, the discussion of the herbarium, etc., had to be published in a paper journal. So a physical journal that was printed and bound and put in libraries. Now, these things were few and far between. They had a huge backlog of publishing that they needed to do. And so at that same meeting in 2011, they decided to allow botanists to publish in online-only journals, which again is going to speed up science. Now, the problem that we have in the botanical community, and actually all taxonomic communities, there's quite a few problems I know of for a fact in like snake groups, etc. Certain kind of rogue elements, people, oftentimes hobbyists or people with very specific agendas, can go through this whole process and formally change the names of things. So there's this like guy who apparently his whole jam is describing new, quote unquote, new species of rattlesnake. So something that like looks slightly different from others, he just elevates as a new species. And the entire community, because he's following these minimal steps in the animal taxonomy community, they have to deal with it. They can't just ignore it. So that means you have to like counter publish and say it's invalid over and over again. So it's cool. We're making some things easier, but kind of opening up the process to more involvement from lots of people. Okay, so it can be validly published, but not necessarily good. So we have some work to do on that end. Okay, now there is a similar type method for all of the hierarchies above species as well. So in the case of something like Solidago canadensis, L, described by Linnaeus, this was the very first named species in the genus Solidago. Now, Solidago has lots and lots and lots of species, but canadensis was first. Therefore, the specimen that is tied to Solidago canadensis, it stands for that species, as well it itself is the type specimen for the genus Solidago. Okay, now Solidago is in the giant family Asteraceae. So Asteraceae as a family is typified by a different genus, Aster. And which aster? Well, the very first one ever described, Aster amylis, which is Italian. Okay. So when you think of Asteraceae, so the specimen Aster amylis is the type for that species, the genus Aster, the family Asteraceae. Beyond that, the order Asterales, as well as the subclass Asteridae. So it stands up high. Now, this type specimen of Aster amylis is from a time even like so long ago. So you can actually see kind of an image of the plant here. Here is the original handwriting by Linnaeus himself and the actual specimen itself. So that stands, that entity stands as the type for all of that hierarchy. Okay, so here's where it gets really interesting. We have determined through molecular systematics that Aster, which was a giant genus of probably 100 plus species, is not monophyletic. Species are coming out in different clades from each other. We're going to see that in just a second. But keep in mind that the real Aster, who gets to maintain the name, is wherever Aster amylis goes, and it's from Europe. Okay, so here's like a quickie poo phylogeny from back in the day, and the line here is showing where Aster amylis falls out. And its closest relatives were other genera, so not Aster, but other types of Asteraceae from throughout Eurasia. Now, I grew up as a botanist, and most botanists I knew were seeing other little daisy-like things all over North America, and we've been calling it Aster for a really long time. So many species of Aster. Well, it turns out the North American Aster clades are related to other North American genera of Asteraceae and are not close relatives of Aster amylis. So here's some of the relatives of the North American asters. So lots of different things. Another way to think of it is whatever defined Aster prior evolved repeatedly on separate continents. So what that means is that all of the North American asters had to have their name changed. And the word aster was so nice to say, but the new name I think kind of sucks, Symphyotrichum. So this is New England Aster, Asta Nova Angliae. And now, and it was really described by Linnaeus, now it is Symphyotrichum Nova Angliae L, and then Neeson, a person, actually did the work of changing that. And so why Symphyotrichum? Well, we're going to talk about that in just a second. Priority on prior names. Okay. So thinking about type specimens, etc. What is this type for all of flowering plants? Believe it or not, it's actually a magnolia from the United States. So a little bit of pride. So thinking of all flowering plants, the descriptor for the entire thing is the phylum Magnoliophyta. So all of that is tied to a specimen of Magnolia virginiana from the southeastern US, I think from Virginia itself, and it was described by Linnaeus. So a little point of pride for the US. Okay, so we see that names are based on this idea of type specimens, and it goes up the rank. There's 8 large and a couple weird families that are allowed to keep old names. You may see some of these weird names from time to time. So Asteraceae, the ACE names on the left are all valid, but sometimes we keep like really old names from before we had the type kind of method. So Compositae, Gramineae, Cruciferae, Umbelliferae, etc., etc. Just so you know what that is if you ever see it. They're kind of synonymous names. As I said, there can only be one accepted name for a taxonomic group. So you could not use both the Vernonia noveboracensis and Sericula noveboracensis for the same species. Only one is accepted. The others are synonyms. The names must be Latinized, but we're kind of lazy with our Latin. So it's kind of a Latin light treatment of it, but it should be like basically Latinized. So Moela is just the reverse of the word allium. So I don't think that's good Latin, but they got away with it. That's what genus is of that pretty little thing. Okay, which name wins is based on a rule of priority. So whatever was published the furthest back in time, starting from Linnaeus's Species Plantarum in 1753, whatever was published from that point on, the earliest is the accepted name. So if it was found that there were 2 competing names for the exact same species, whichever one was earliest would win. That is the rule of priority, right? So if you were to look at all of this about a species of penstemon, one of the nightmare genera of Colorado, hopefully you could say, well, if Linnaeus did it, it's good to go, right? So you can see there's lots of people that have done different works on groups that their names are not recognized. And there are very certain publications you can look to actually find all the synonyms. It's sometimes given in monographs and other descriptions of names. Now, the botanical nomenclature or name rules are independent from zoological nomenclature. This is kind of fun. You can have the same genus used for plants and for animals. So both of these are Cecropias. Both of these are Pyrrhus, Heliconia, and Heliconius, which are in the same habitat and involved ecologically with the Heliconians. I might have mentioned this in zoological nomenclature, the genus and the specific epithet can be the same word. In the case of botany, they cannot be. Okay, so to kind of quickly review everything we just did, we talked about common names and some problems with them, and that was really focusing on kind of English common names. We will now consider indigenous nomenclature in a moment. We talked about polynomials, which was like a genus and then a whole list of its descriptors, and then showed that a binomial or 2-word name schema for species is a much better way to go. We talked about a scientific name is that binomial plus its authority. Synonyms are duplicate names that cannot all be recognized. There can only be one true name at a time. And we talked about the type method. So every species name must be linked to a holotype in an herbarium. Okay, take a breath. So will I. We're moving on. Okay, so that was to get to the name of a species or the name of a family or a genus or whatever. Now, how are those things all interrelated and classified? And what features do we look to develop different groups and their relationships to each other? Okay, so there has been a long search in the history of Western science for a system of classification that is quote unquote natural. And we'll talk about kind of what that idea of natural is. There are parallel systems of nomenclature being very well developed outside of Western Europe, particularly in India, ancient India, China. The Aztecs and the Egyptians had their own very well-developed systems of classification. And then we'll talk in broader about folk classification globally of indigenous peoples worldwide. And I would argue that kind of the take home is all humans across space and time and culture perceive biodiversity in very similar ways. We see similar groups, we're able to infer relatedness at some level. There's certain features that we really want to talk about. And so I think kind of these different systems of names kind of all go hand in hand. And so we shouldn't reify the scientific above all others. Okay, so now let's consider indigenous folk classifications. So globally, and again across space and time and culture, people have had the need to communicate about plant groups. So ethnobotanists have lots of really cool jobs and roles that they play. One cool sub area of ethnobotany is thinking about nomenclature. And again, I'm kind of at the edge of my knowledge here. This is not really what I do, but I would say if you're interested in this, kind of like linguistics, anthropology, and botany, like there's really cool classes you could kind of combine here to do a deep study on that. So people are finding the need to communicate about plants to each other, right? And what ethnobotanists have found through, careful study within different groups of people is that there is definitely a hierarchical language that indigenous groups use, just like Western science does. Oftentimes kind of the highest level is going to be like a unique beginner, kind of the equivalent of kingdom. So the beginning of the language often is like, is it a plant or is it an animal? And then there's going to be like 5 or 6 categories under that, which are often roughly equivalent to what, Western science, the Linnaean hierarchy would come up with as well. So after that unique beginner, then we jump down to like life forms within plant. So things like trees, vines, grasses. In certain areas, like especially like the New World, something like cactus-like form, the Mayan people would distinguish that as a very distinctive life form to discuss. However, if you are from the Amazonian region in Peru and you see a lot of these strangler vines and trees, that would be elevated to life form, whereas you wouldn't see that in other parts of the world. You wouldn't even really know how to place it at that level. Okay. Then below life form are kind of smaller clusters that are somewhat equivalent to genera. Now, most nomenclatural systems of indigenous groups have at most 500 of these kind of split up. That's kind of like the workable level of a language. And that's a really similar level to what Linnaeus and earlier like Greek predecessors like Theophrastus will talk about. We're talking about. So again, like there's kind of a level at which humans like to organize information. And this is the level at which most of the discussion happens, right? We're learning genera. This sort of level of organization is how indigenous groups communicate to members of their community. Then under that are smaller kind of species or specific and varietal levels. Within a genus, there might be only 1 or 2 or 3. However, if the plant group has very specific specialized uses, foods, fibers, medicine, ceremony, etc., then they might describe a lot. And we will consider, is this a one-to-one match with what Western science would find, etc. Okay, so this is some of the great work that Emily Rafidi did for me last summer on Indigenous Nomenclature. And she was looking at ethnobotanical studies of our region's indigenous peoples and was finding kind of ways of grouping the translations of their names. So some indigenous names would translate to a distinguishing property of the species. So the Arapaho word for Abies bifolia translates to good smell. And I think it would be disrespectful for me to try to pronounce these words because I have absolutely no idea how to do so, but you can read them here. And if any of you know anything about that or resources, please let me know. I really would love to know how to do that respectfully. Similarly, Ribes cerium kind of translates in Arapaho to hairy or fuzzy, which it very much is. And Astragalus, the genus in general, translates to a plant with a long root in Navajo, which indeed it does. Other indigenous names are descriptors of use categories. So like the Ute word for Achillea millefolium is wound medicine. Euphorbia incisa is the Navajo word for how to give birth, indicating what you might be using it for medicinally. Now, there are definitely some species that the names from different tribal languages translate to a very similar thing. So both the Navajo and Arapaho names for Achillea millefolium translate to something like a squirrel's tail. And the Arapaho and the Shoshone names for Ericameria translate to rabbit bush, which is exactly what the Western or English common name is, probably which they might have heard it from indigenous peoples first. Some indigenous names are describers of how animals use it, so bees food, hummingbird food, etc. Some names combine features and uses like slender odorous medicine, round flower medicine, etc., etc. Okay, and what do we find? Well, we find that there is generally a really high one-to-one correspondence between how Western science would name a bunch of plants in an area compared to how the indigenous peoples of that area would name them. So here is a study of the Mayan peoples area. And there was a number of genera, so 471 genera were surveyed, and the vast majority had a one-to-one correspondence. So 62% of those matched, quote unquote, what the quote scientists would say, right? And similarly, different tribes all have a single name for Juniperus scopularum, which has a single name to Western science as well. And similarly, the Navajo tribe can distinguish between species of Atriplex, which are quite similar with different words, just like Western science would, one-to-one correspondence. Now, in some cases, and again, in the study of the Celtal or the Mayan people, right? There's a couple different ways in which the indigenous people under-differentiate what Western science would say. So they group all of the different lantanas together into one, whereas there's quite a few. They might not distinguish in some cases between Pinus and Abies, whereas Western science would say they're quite different. Now, the other case is over-differentiation. All right, so thinking of all of the different words that indigenous South Americans have for domesticated potato, which Western science would say is one species, or pepper, or something like that. So examples locally are that there are multiple names by the Navajo for Erodium secutarium. There are multiple names by the Arapaho for Arctostaphylos uva ursi. Now it's unclear if those people would apply different names to the exact same plant or to different forms of the plant. That's what I don't know here. So they could be recognizing difference, or they could be using just different words for the exact same plant at the same time. I am unsure about that. These over differentiation happens to be in cultivated plant categories in general. So here's 4 different indigenous groups, and we see that the cultivated category of plants is by far the most likely to be quote unquote over differentiated, in which way more words exist for useful plants than Western science would dignify, because Western science is not specially annotating different uses, but rather biological species. So here's one of those studies, the Hanunu people of what is now Sri Lanka, as well as some of these other groups, and considering again how Western science would group genera and how many species are in a genus. So on the left is like the number of genera and then the number of species within them. People worldwide tend to have 1 to a couple species in most genera, and then it gets bigger from that. But then the quote unquote Western scientists who wrote the Flora of Ceylon said very similar things, how they grouped species into genera. So humans are perceiving biodiversity and classification in really similar ways, whether they are trained and practiced in the Western taxonomic tradition or indigenous people interacting with biodiversity, communicating about it to the next generation. Okay, so now let's consider the Western arc across time, about how essentially do we get to the APG4? Where did we begin and how do we translate to phylogenies? Okay, so we have kind of this arc from artificial classification to natural to phylogenetic. So artificial is going to be kind of pre-Darwin, pre an understanding of evolution. Natural is going, well, and more like based on very few key features. Then we start to consider lots of suites of characters, but not really knowing which ones to prioritize, moving into the natural. And then the transition from natural to phylogenetic is Darwin and evolution. So from there on, it becomes our understanding of grouping should be based in evolutionary history solely, and that's kind of where we move. So that's the overview. Now I'm going to kind of deep dive into that. Okay, going back to 300 and whatever BC, here is Theophrastus, kind of the great Greek, great grandfather of botany. And he's a student of Plato and Aristotle, and took the philosophical idea of essentialism and applied them to plants. And kind of his idea is that a genus or any group of species should be described based on one or a few just essential properties, like boil it down to one thing only. So something like being an herb, which is a form of habit, is an essential character. Subshrub, shrub, tree, right? And he saw a very clear linear gradation used to arrange organisms. So interestingly, these are some of those kind of life forms that we saw in folk classification as well. He and so many of the other early thinkers in this area very much have this kind of ladder of progression idea operating behind the scenes in their brains as they try to understand biodiversity. Okay, so this is the chain of being or the ladder of life concept I was just talking about. And the ladder of life, I go into this a ton in my evolution class, is a fallacy. And it leads to false ideas of relationships. So what's highlighted here is at the very top is humans, and then there's fish in the middle and mollusks right below it. So if you arrange animal diversity in a ladder, you could have an idea that humans are the best, and there's this upward progression towards awesomeness or complexity or whatever. And that things that are close together, like fish and mollusks, are more closely related to each other than either are to humans. We know that to be not the case at all today. There is not a unidirectional kind of ladder of biodiversity. But that's what the ancients thought, and that idea pervades so much of thinking up through Darwin and even into today. Okay. So a branching tree puts everyone on the same level, not that you can tell that here, the way that it's drawn. And it's rather about the orders of common ancestry, right? So a fish would be more closely related to humans because their common ancestor, A, lived more recently than the common ancestor shared with mollusks. So this is like the early thinkings of tree thinking and phylogeny. Okay, but Aristotle and Theophrastus were nowhere near that. Okay. So this is kind of problematic because if you were going to group all the trees together, right, you would throw gymnosperms in with woody angiosperms, et cetera, et cetera. It's a useful way of communicating, but it's not at all reflective of evolutionary reality. It's a pretty logical system, you could describe it, but it's pretty rigid, and you're just prioritizing what's called a priori, or you pick kind of ahead of time a thing and you just go with it. So we a priori valued having a woody trunk as what unites all trees. What we would know now, right, is it's all about having carpels, yes, no, angiosperm versus gymnosperms that would split those things up. But the a priori choice of woody trunk would unite all the trees under this artificial classification scheme. Okay, so there has been a long history of people writing and describing about medicinal and useful plants. The herbalists that we're going to talk about. So like the very first texts where we get long descriptions of useful plants, right? So do you remember our Diascoria, that was that long vine, which is a monocot with net-like veins that we saw? Well, here's some pictures of it, including its fruits. And it is an incredibly important medicinal plant. It's a source of steroids, cortisones, the first oral contraceptives, hormones, et cetera, can be derived from this. So herbalists would want to be able to describe and group this with other useful plants. Okay, so here's some examples of ancient herbalist texts. The name Diascoria goes back to honor Dioscorioides from AD 60, who published this book in which the medicinal plants were described and grouped based on their medical properties. So just like we could critique groupings based on woodiness, now the herbalists, they start grouping plants based on their uses for humans, right? Okay. And this goes on for many, many centuries. If plants were described at all in the Western world, they would have been described in these herbalist texts. Really bad times, lots of plagues, draw an interest in herbalist medicine into the 15th and 16th centuries in Western Europe. Dark times, right? And of course, the printing press allows us to transmit printed information about plants into actual books. Now, within these books, you might just alphabetize the plants or just group them based on like good for childbirth, good for pain, etc., etc. There were not that many species known to Western science at this point in time. So it was kind of easy to, fit all known plants into a book at that point in time. There was no need for an extensive classification system. It was possible to know all plants and be able to quickly look up what their uses were. These often have beautiful illustrations. Germany in particular really takes this to the next level. Um, and many of our plants today actually are honoring some of the earliest herbalists. The genus Fuchsia is named for Leonhard Fuchs, an herbalist. The family Gesneriaceae is named for someone, etc. Okay. So then to the very few educated white men for whom this mattered, right? The world's about to get a lot bigger. So starting in, the 1600s, the 1700s, the quote unquote age of exploration, we have major boat trips going to various parts of the world for various reasons. And oftentimes botanists were on board collecting en masse plants as well as all other living things and bringing them back. And in particular, they're bringing them back to a dude in Sweden, Linnaeus himself. So this is showing where Linnaeus, but more his students went. Linnaeus does like one big trip to northern Sweden, and that's it for life. And then he just hangs out describing species. And his students go all around the globe collecting, and bringing it back. And there's so much more biodiversity than anyone ever realized. And it becomes clear that just shoving everything into a book based on use categories is not going to cut it. The world is so much bigger than anyone knew. One of the big explorers, Sir Joseph Banks, his exploration encounters to Western science, certainly just there were people everywhere interacting with plants, but to the Western world, he brings back lots of information about plants from South Africa, Australia in particular, and New Zealand. And there's a beautiful genus Banksia named in honor of him. Okay, so we need to classify all of this biodiversity, and maybe we need whole suites of characters. Just finding one thing like good for pain isn't going to cut it. Okay, so prior to Linnaeus, this guy Cecil Pinot, who the sessilpinoid legumes are named for today, he's kind of one of the first people that struggles with how to classify plants in a quote unquote natural way without just picking one thing as a human and going with it. He collected a bunch of plants. He's kind of one of our first plant collectors that we actually have specimens from today in folios, in books. And he's the first person in the Western world that starts to arrange plants based on the reproductive features. So really looking at flowers and fruits without kind of a human lens on it as much as possible. So we attribute the first natural system using a suite of characters from flowers and fruits to him. We attribute the world's first herbarium to him in Italy, and the first botanical garden. So bringing together plants, especially plants coming from other countries, in cultivation to show off and to arrange your garden in a quote unquote natural way, reflecting relationships. We don't know about evolution yet, but relationships. Okay, moving over to England, 1600s, early 1700s, John Ray argues that we need to consider the entire plant. And he classifies 18,000 species, again, prioritizing fruits and also considering flowers and leaves. He's the first one who recognizes the distinction between dicots and monocots and kind of authors many of the orders that we still consider today. Pierre Magnol, he's going to get the magnolia named for him. He thought that that was a little bit too cumbersome, taking it to French. They hate everything British, right? And he's going to start to consider family level relationships. And the family Magnoliaceae is honored for him. And now here's Linnaeus, the real guy, so Swedish. So we considered a bunch of different European white men. Now we're back to Sweden. And he kind of combines the work of all of these into a workable classification system that can incorporate all of the new species from the globe being brought to him. And this is not just plants, right? He does this for animals as well. Now, for plants, he writes a book called The Sexual System. And we'll talk about that in a second. However, this is kind of a step backward from the botanical kind of community, because he really is going to focus on one particular sex part. Okay, so with a measly $125, which was a lot of money in 1732, he went for 5 months to Lapland, northern Scandinavia, and did a 5-month collect everything possible. And those collections that he made himself begin kind of the backbone, the structure for how he folds in the flora of the world. But that's the only time he ever goes anywhere. The rest of it is just his students bringing stuff back to him in Sweden. Now, I should say, I mean, he is a very devout Christian, as are practically all scientists at that time. And in his mind, the order and the structure of biodiversity that he sees is the mind of the creator. So he sees it as his role on earth is to make clear the mind and the genius of God in discerning all of these groups of living things. So he does not at all think that living things evolve and change over time and have common ancestry. No, he thinks that the order and structure we see in biodiversity is the mind of God, the creator. Okay, so his sexual system is written in Species Plantarum, 1753. And he chose, again, he kind of does that problem. He just picks one random thing a priori because it's workable. So not the best. What does he pick? What does he love of all the various parts of a plant? He's a dude. He picks the number of stamens as the way he is going to arrange plant biodiversity. After that, second fiddle is the number of pistils. Was he a sexist? Probably, but for his point, there was just a lot more variation in the number of stamens than in the number of pistils. So just dividing up all of botany based on the number of stamens created a workable system for him. Okay, so how does this work? Here's Oenothera biennis, or the evening primrose, and it has 8 stamen. So he would have placed this in a group called Octandria at the first level. It has 1 pistil made of 4 fused carpels. So the secondary term, second level, he would have placed it as monogynia. So within Octandria monogynia, he includes other things, including the genus Guara and the genus Epilobium. Now, today we know those are all members of the plant family Oenograceae. So he gets a lot right. And that's why a lot of plant names and groupings today still have that L with nothing else after it, because he did discern many evolutionarily sound groups through his systems. Now, he did know there were some problems. He knew it wasn't perfect. His system would have grouped together cactus and cherries together. They have tons of stamen and a single pistil. He's like, but one's a tree and one's a cactus, but we're throwing it all together. He was okay with that level of conflict because he just wanted this system to be usable, predictable, expandable as more species were discovered, and immutable. So that's kind of a critical idea, is that species don't change, that these are fixed features that go on forward. So it's not that great, but Linnaeus in general, he does more than this. The whole Linnaean hierarchy is above him. And then just basically describing species in general, a lot is attributed to him. Okay, so after Linnaeus, right, we have more and more plants being brought into Western European knowledge, into collections, the beginning of major botanical gardens, etc. But taxonomists, especially botanists, really again wanted to kind of look at suites of characters as opposed to just the one thing that Linnaeus cared about. I've never been there, but in Uppsala, Sweden today is the massive garden attributed to Linnaeus with all of these groups of plants that he authored laid out just so. That's a thing I really want to see someday. Okay, so back to France, Des Jusseaux, which is a group of botanists out of Paris, produce a much more complete natural classification looking at many suites of characters. And they're really thinking about arranging plants in gardens in groups. So the magnificent gardens at Versailles in Paris are kind of mimicking that look and feel of grouping relatives together based on suites of characters so that they could be in close proximity to be viewed by people together. And some botanical gardens kind of continue that practice on to the day. Okay, then all of these attempts at grabbing at groupings and why are there groups, whatever, that all gets kind of blown up, starting with Darwin, of course. 1859, publication of Origin of Species. We talk about this ad nauseum in evolution class, right? We are going to move to prioritizing evolutionary relationships and a new way of understanding characters in terms of primitive versus derived or advanced. Okay, so the idea of this natural had many different things to different people, what features we should use to group, right? So Linnaeus and most others were saying, well, the features I'm seeing that allow me to make groups are, again, referencing that structure of the universe as ordained by God, specific or special creation, the mind of the creator. Others would not infer God explicitly, but there is some kind of sense of relatedness or genealogy, but it's not specifically common ancestry and evolution. Darwin, though, of course, through Origin of Species, says that there is relationship plus change over time, right? So classification or groupings must reflect ancestry or genealogy. But that alone cannot give us a classification. We have to have change over time, right? So evolution is descent with modification. So genealogy, descendancy, and change of features, right? And all of these descendancies and the features that change along branches can be depicted as a phylogenetic tree, which is a metaphor, which is a way of organizing information, but it is kind of what we do to the present, right? So common ancestry of all of the things alive today at different levels is a fact. The outcome is a phylogenetic tree. The first time this is really depicted visually is by one of Darwin's greatest champions, Ernest Haeckel, the German, who publishes this first tree of all life. And every single classification of plants and animals subsequently to Darwin has been phylogenetic, trying to emphasize the evolutionary history, not just random features that humans picked, but the actual structure of evolution. Okay, so Darwin was so close friends with so many botanists. He was actually a very good botanist in his own right, but he was a very close friend of some of the key botanists in the UK, Bentham and Hooker in particular. And they were in charge of the early Royal Botanical Gardens, which is a splendid place. I was an intern there right out of college. And it is a former royal ground with all of these amazing glass houses where in the Victorian era, water lilies, palms, things like that brought back from the tropics were cultivated so that people could see and observe them. And so these gentlemen were in part responsible for how do we organize and understand all of this biodiversity there. They are going to interpret botanical biodiversity for Darwin and giving him many lines of evidence for evolution that he probably wouldn't have seen without them. And they kind of come up with a system post-Darwin of how plants are arranged, but their work is overshadowed by some upstart Germans, Engler and Prantl. And they're kind of publishing right around the beginnings of the 1900s. And this is kind of where we start moving into like textbooks I've seen as I've come of age. And so they emphasize simple versus complexity. So kind of setting up a gradation of different characters of plants. And that the threads of their thoughts are kind of like still in a lot of herbaria, floristic treatments, keys that we see today. So this is kind of the beginning of the modern era. So their idea of a simple flower, they thought that that would have few or no parts. That would be primitive. So salix, which we've talked about, or the willow, that has each one of those tiny reduced flowers has no sepals and petals, really. So that would be a primitive idea to them. So the old family, the Amentiferae, which we now have broken up into Salicaceae and others, were considered primitive. That's not at all what we would say today, but it was a thing. It was a thing. They had an idea of simple, and this is what they went with. Okay, now moving to the US, yay. Charles Bessey, University of Nebraska, continues on with this primitive versus advanced characters idea and hypothesized what are the states for plants. And again, we see his rules kind of impacting everything today. He's kind of the founder of modern American botany. Okay, so to him, a primitive state for floral parts would be all present, many in number. That's what I've taught you, right? We talked about like the magnolia idea. And an advanced state would be losing those. So that's really in contrast to what we just talked about with the willow. Fusion, the primitive would be parts separate. The advanced would be parts fused. That's what I've taught you. Actinomorphy as primitive state and zygomorphy as advanced. And the ovary position is hypogynous as primitive and then epigynous as advanced. So that's, you know, again, what I've taught you as accepted today. It goes back to him in the early 1900s. So again, kind of a magnolia as primitive sort of idea where all is leaf kind of originated from, we associate with him, reduction, loss, and fusion. He arranged all, he kind of like drew the lines and the boundaries on the orders, and then he arranged them in a cactus-like diagram here. This is called Bessey's cactus. And this is like legit what I was taught in college as valid and accepted today. It was not at the time I was taught it, but my professor had never updated his notes. So this is what I learned in the early 2000s as how we understand evolution in plants to work. And again, we would kind of place magnolia and friends kind of at the base of the whole tree. And then we have kind of two different trajectories, for sympetally, so fusion of petals, hypogeny, epigyny, actinomorphy, zygomorphy, kind of the different branches moving out from there. And then all the orders kind of arranged along that. So you can like look at that and see some of the things that we've seen. Now, some of that's good and some of that's not. A major problem with that is that when you depict evolution this way, there are things that are kind of like ancestors of things that are out at the tips. So I'm looking at something like, here's the Celastrales here, and it's like in between things. And so this is a vestige of that ladder of life fallacy. Every one of these orders is alive today. Therefore, it is equally evolved to everything else that's alive today. A depiction of evolution like this can lead to conclusions that an entire order or an entire species or family or whatever that is alive today is more primitive than something else. That is not true. Everything that is alive today is equally evolved, but certain feature states that they have might be considered more primitive. So magnolia is equally as evolved as a grass, but most of the features that magnolia has in its flowers, we would associate with being primitive. So then we kind of end back where I began you a long time ago with the APG, molecular systematics, DNA sequencing, building the true phylogeny of angiosperms. So that is all I've got. Thank you for bearing with me. I hope you found that interesting, and I will see you soon.